Hi, it's me again, and this time we get the really fun stuff. We're going to be adding and subtracting rational expressions without like denominators. So the hard part of this is getting the common denominator. So what I'm going to do is start with a numerical example and then move over to an example with rational expressions and polynomials. So the first thing you need to do is factor each one of the denominators to figure out what the least common multiple would be. So 14 would be 2 times 7, and 21 would be 3 times 7. So sometimes I think, okay, I'm going to make some columns to let me find what the least common multiple is, or the lowest common denominator, and for every new factor, I need a new column. So I have a factor of 2, and 7 is a new factor, so there's a new factor there. And then I come over here, and 3 is also a new factor, but 7 is already there. So it goes in the same column. So then I look at the total. The total least common multiple would be 2 times 3 times, 2 times 7. I'm jumping ahead of myself here. 2 times 7 times 3, which would be 42. Now this total doesn't really matter, but we want to look at the individual factors. So since 14 was 2 times 7, we look, okay, we need to make it 42, but this has the 2 and the 7, and it's missing the 3. So what I need to do is multiply the denominator by 3 and the numerator by 3, by whatever the missing factor is. And the 21 has the 3 and the 7, but is missing the 2, so I need to multiply this by 2 and this by 2. So to get this whole thing, now we would have, so I'm going to have the denominator, and just like over here, I'm going to write it in factors. 2 times 7 times 3. And the numerator would be 9, which is 3 times 3 minus 4. So that would equal 5. And since there's 5 and there's no common factors, so we can't reduce that. So it would be just 5 over 42. But the process that I'm wanting you to get is you figure out what the least common multiple is by figuring out what are the common factors, because you don't need to count them twice. Like we didn't want to just do 14 times 21. That makes the numbers too big. We always want to make our numbers smaller. All right, so moving on. All right, so now we're going to move over to a rational expression with polynomials in the denominator. So we do the same thing again. We are going to factor each denominator so we can find the lowest common factor. So we're going to factor this x squared plus 3x minus 4. And that would be x and x plus 4 minus 1. And this one factors into x, and it would be plus 3 minus 1. So we can go over here and find our least common multiple. And again, we're going to make columns like this. So the first column our first factor is going to be x plus 4. And then we have an x minus 1. That's a new factor. And x plus 3 is a new factor, so we have an x plus 3 here. And then we have an x minus 1, so we don't need to add a whole new column for this. So our whole lowest common denominator would be x plus 4 times x minus 1 times x plus 3. So that means each one of these is going to have a denominator that is that. So what I need to do is this denominator has turned into this. This denominator has turned into this. So I look and say, what is the factor that's missing? X plus 4, x minus 1. This one is missing an x plus 3. So we're going to put this in parentheses and multiply this times x plus 3 and multiply this times x plus 3. So now we have the whole denominator that we need. This one has an x plus 3, x minus 1, but is missing the x plus 4. So we're going to put the x plus 4 in the numerator and the x plus 4 in the denominator here. So As I said before, one of my hints was to write this with the correct denominator. So it's going to be x plus 4, x minus 1, x plus 3. And I'm going to leave that. One of my hints is you never want to multiply out the denominator. The denominator should always be in factored form because you want to be able to reduce it. The numerator, on the other hand, you need to multiply out the numerator, combine all the like terms, and then hopefully refactor it. So we're going to FOIL this. This is going to be 5x squared, and then be plus x plus 15x, so it'd be plus 16x, and then plus 3, because 3 times 1 is 3. Now, I don't know if you remember, this negative sign is easily lost, so you want to put it up here. So I'm going to do plus and then a negative 3x there, so that I don't lose it. So negative 3x times x is going to be minus 3x squared, and a negative 3x times 4 is going to be minus 12x. All right, so now I'm going to do some combining. I'm going to write that denominator, x plus 4, x minus 1, x plus 3. And 5x squared minus 3x squared is 2x squared. 16x minus 12x is plus 4x. And then it would be plus 3. All right, so now, just like up here, we check to see if the 5 could factor. So this, we now need to refactor. We had to combine everything by multiplying, and then we're going to see if this refactors. And so we have 2 times 3, which is 6. We want to add it to 4, and there is nothing that works for that. So our final answer, since nothing can factor out of this can't factor, especially it can't factor into one of these common factors, that is our final answer. The hardest part of this is getting this common denominator, making sure if it's 2 terms times 2 terms, you FOIL it. There's that negative sign, you want to bring it up to the numerator so you don't lose it. Making the chart over here for the least common multiple is helpful. There's a lot to this, so I hope this helped.